Hello friends, now today we are going to see application of double and triple integration. The very first application that we are going to see of double integration is how to find out the area with the help of double integration. So the formula for area is double integration dx dy when you are having a Cartesian equation. And if you want to find out in polar, then the value of the area, the formula of the area is double integration r dr d theta. Okay, in that case we are going to replace x by r cos theta and y by r sin theta. Okay, so directly we'll see one example of how to find out the area with the help of double integration. The example is find a double integration the area between the curve y square x is equal to 4a square 2a minus x and its asymptote. So here we are supposed to trace this curve first of all, and once you have a curve and its asymptote, we are going to find out the area between them. Okay, so if you remember the curve tracing, if the power of y is even, then symmetry is about x-axis or this thing. So with the help of that curve tracing part, we are going to trace the curve, and your curve will look like this. Now basically what we want to find out, we want to find out this area. हमें ये area find out करना है. Okay, now how to do it? So we are having a region, and with the help of the region, first of all we'll try to get the limits, and once we have the limits, we'll find out the value. Okay, so required area is 2 times double integration dx dy. Okay, now it will be depend on you whether you are taking a strip parallel to y-axis or strip parallel to x-axis. In this problem, we have taken a strip parallel to y-axis, and therefore we have to integrate with respect to y first and then with respect to x. The limits of y that you are going to get over here is y is equal to 0, and here you are going to have y on the curve, where you are going to have the value of y as 2a into root of 2a minus x upon x with the help of the equation. And then I am going to move the strip from this point to this point. So here your y will be, x will be 0, and there your x will be 2a. So x will vary from 0 to 2a, and y will vary from 0 to 2a into root of 2a minus x upon x. Okay, one more thing, if you look at the curve, this is symmetric about x-axis. So whatever area is there in the numerator, this upper side, the same area is there over here. So what we'll do, we'll find out the area of above the x-axis and we'll double it, and that's why we have written here 2 times. Okay, 2 times the area. So it will be 2 times 0 to a, 2 times 2a into root of 2a minus x upon x. Okay, now first of all we are going to integrate with respect to y. So integration of 1 with respect to y is y, and then we are going to put the upper and the lower limit. So upper limit is this and the lower limit is 0, so we are going to get the same thing. And when you integrate with respect to x, that 2 we have taken out, so this 2 into 2a will give you 4a outside, and there we are going to have x raised to half and 2a minus x raised to half dx. Now here we are going to make use of beta function. Now if you remember the definition of beta, x raised to a minus 1 into 1 minus x to the power n minus 1, then it is beta of mn. So it is exactly of that form, and since we want 1 over here, we are going to take 2a common, and once you have 2a common, here you are going to have x upon 2a. So what we are going to do, we are going to put x upon 2a is equal to t, so you are going to have x is equal to 2at, so dx is equal to 2a dt, and so on. So when you substitute this, your equation will look like this will be your equation in terms of t. Okay, and when you simplify it, you are going to get it as 8a square beta of 1 by 2 3 by 2. Now we know the beta gamma relation, so it is beta mn is equal to gamma m into gamma n upon gamma of m plus n, that we are using over here. So it will give you 8a square, gamma half is root pi, gamma of 3 by 2 is 1 by 2 into gamma root pi, gamma 2 is 1 factorial, that is 1. So when you simplify it, you are going to get the answer as 4 pi a square. So this is the area between the asymptote and the curve. I hope you are getting the idea. So the thing is very simple. You are supposed to remember the formula. Area is double integration dx dy or r dr d theta, and then simply if the region is given to you, you have to consider a strip parallel to x-axis or parallel to y-axis, and you can easily do it. So this is about area. Now we are going to see one example on volume, that is the application of triple integration. Now the formula for the volume is same as area, only the thing is here we are having one more dimension. The volume is triple integration dx dy dz. Okay, so let us see one example on this. Prove that the volume bounded by the cylinders y square is equal to x, comma x square is equal to y, and planes z equal to 0 to x plus y plus z is equal to 2 is 11 by 30. So basically try to understand the thing. Y square equal to x is a parabola, x square equal to y is also a parabola. So the intersection of these two that you are going to get is something like this, that is there in the diagram. Now this part we are going to move from 0 to the plane x plus y plus z equal to 2, and when you move this you are going to get a cylinder there. So if you observe over here, your z will vary from z equal to 0 to that plane x plus y plus z equal to 2. So the limits of z that you are going to get will be from 0 to 2 minus x minus y. So we are having the limits of z. So while solving the problems of volume, first of all try to get the limits of z. Now once you have the limits of z, integrate with respect to z, and you are going to get the answer as v is equal to double integration over the region R 2 minus x minus y dx dy. Now it will convert into double integration. Okay, now when you have a double integration and we are having the region, now to this region we want to find out. So again consider a strip in that region as we did in the previous problem. Same way, either consider a strip parallel to x axis or parallel to y axis, and you are going to get the thing. So if you consider a strip parallel to y axis, again your y will vary from x square to root x, and your x will vary from 0 to 1. So that value we are putting over here. So and when you simplify it, you are going to get 2y minus xy minus y square by 2, and then we'll put the upper and the lower limit, and then at the end we are going to integrate with respect to x, and then we put the limits as 1 and 0, and when you simplify it you are going to get the answer as 11 by 30. So in a volume problem, what you are supposed to remember is, first of all try to get the limits of z. Whatever limits of z you are getting, put it over there, simplify that part, it will convert it to double integration, and then either draw a strip parallel to x-axis or y-axis, and you can solve the problem further. Okay, so that is about volume. Then the next application of is again a application of double integration. So with the help of double integration we can find out the center of gravity. Even we can find out center of gravity of solid also. There we are going to require triple integration. So generally the center of gravity is denoted by x bar comma y bar. So center of gravity is the point where it balances the curve. Okay, so here if you look at the, or it is generally on the at the center. Okay, so here the formula for x bar is the integration x rho dx upon integration rho ds, where ds is the rectification of curve. So I hope you remember the formulas in the rectification of curves that we did. We are going to require that over here. Similarly for y bar. So look at the problem. Find the center of gravity of the arc from the cusp to cusp of the cycloid x equal to a theta minus sin theta, and y equal to a 1 minus cos theta. So if you remember, this is the cycloid. So what do you want to find out? We want to find out the length of the curve from this cusp to this cusp. So this part we want to find out. This length we want to find out. Okay, center of gravity of it. Okay, so here this cycloid is symmetric about the line. This line, it is x equal to a pi. This is symmetric about that. So since it is symmetric about the line x equal to a pi, your center of gravity is obviously on this line. So your x is equal to a pi is fixed. Now what do you want to find out? Only we want to find out what will be the coordinate of y. So we are supposed to find out y bar. Your x bar is fixed here. It will be a pi. Now we want to find out y bar. So we'll substitute the thing in the formula. So ds is equal to under root. Since we are having a parametric curve over here, the formula is dx by d theta square plus dy by d theta square. So we will find out the value of ds first, then we are going to find out y ds, where y already we are having. Y is this, y is given in the problem. This is your y and this is your ds. So we are going to find out the integration of it, and the integration of that will be 32a square by 3, and then we are putting this values in the formula of y bar. So when you put the values of y bar there, you are going to get the answer as 4a by 3. So your center of gravity will be what? Your a is what? A is a pi, and your y bar that you are getting is 4a by 3. So center of gravity is a pi comma 4a by 3. Okay. So here in the center of gravity, what you are supposed to remember is the formula for x bar y bar, and you have to check out the symmetry. If it is symmetric about x axis, then the x coordinate we know, and if it is symmetric about y axis, then we are going to have the value of y. So here, since the symmetry is about the line x is equal to a pi, this definitely the center of gravity is on this line. So x coordinate we know, because it will be always throughout on this line, it will be a pi. So it will be a pi. Only the y coordinate we are supposed to find out. Okay, so this is about center of gravity. You can find out center of gravity of area, you can find out center of gravity of arc. Actually, this is the problem, center of gravity of arc. We can find out center of gravity of solid also. Now this is the last application, moment of inertia. So moment of inertia of a lamina about x-axis, it will be double integration p y square dx dy. Similarly for y-axis, it will be p x square dx dy. What is this p? Now p is nothing but the distance of that mass from the x-axis or y-axis respectively. So we'll see the problem on this. Prove that the moment of inertia of the area included between the curves y square equal to 4ax and x square is equal to 4ay about x-axis is 144 upon 35 m square, where m is the mass of the area included between the curves. Now again, by the formula, the moment of inertia is double integration y square rho dx dy. So here that p distance is nothing but your y. So you are going to have something like this. So again, to get the limits, we have to draw a strip parallel to y-axis. The limits of y and x you will get, and then we are supposed to integrate this thing. Now when you integrate, you are going to get the answer as this: 2 raised to 8 3 rho a raised to 4 upon 35. And then again you have to make use of the formula of mass also. The value of the mass is equal to double integration rho dx dy. From that you are going to get the value of rho in terms of m, and that value of rho we are going to put it over here. So when you use the formula of mass, you are going to get the value of rho as 3m upon 60 square. Now this value of rho we are going to put it in the previous result, and when you do it, you are going to get the answer as moment of inertia is 144 m square upon 35, where m is the mass. Okay, so I hope you are getting the idea. Again, for moment of inertia, you are supposed to remember the formula. What is p? You have to remember, and then simply you have to do the double integration by drawing a strip parallel to x or y axis. Okay, so that's it. That is the end of unit number 6. Thank you very much.